this is a worked example on how to graph sine and cosine functions. So I know that this graphing section of the textbook is probably one of the harder, or at least just chapter 7 in general. The graphs that you draw in this section are more complicated and just unnatural to work with. And it makes it really challenging for a lot of people to graph and visualize sine functions. And I totally get that. So I'm going to try and make this as general as possible in the sense that I want you to be able to apply what I'm doing here to like cosine functions as well, even though I'm graphing a sine function. Um, so before we do anything, let's just apply the theorem 7.6 and let's just find out the values of all of our special um, features. You know what I mean? So the first thing we'll solve for is we want to know the period. And so I guess what I should write down is the format we're looking for is a times sine, and then we use omega. We often use t as our variable, and the Greek letter phi, and then plus b. So we're looking for this form. And anyway, period is 2 omega, or sorry, 2 pi over omega. And so in our case, omega is 2, and so I will get, well, 2 pi over 2, and so my period is going to be pi. Um, this tells us how long the fundamental cycle of the function is, and I'll get to that in a moment, but we're going to keep going. Next, we have phase shift. That is going to be negative phi over omega. And so in our case, we have phi as pi over 2 over omega, which is 2, and that gets us negative pi over 4. And this will kind of be like, is the function shifted left, shifted right? Then the other two we have, I'll write them down, but we're not going to really be using them in this example. We have amplitude, which is the absolute value of a, which in our case is 1. And we have the baseline, which in our case is 0. So the ones we're really concerned about here are period and phase shift. Those are the important ones. What we can do is we can start by using those two values to sort of draw out the area where our fundamental cycle is going to exist. And from there, we can kind of use some clues that we understand about sine functions to fill in the rest of the information. And let me show you what I mean. So let me start by drawing a large graph so we can kind of be very clear in what we're doing here. And hopefully my face cam won't take up too much space. Actually, I'm going to anticipate what this is going to look like. I mean, I already did this problem, but I'm going to shift this a little to the left. All right, now let me draw my other axes. Okay. So really briefly, think about what the fundamental cycle of a sine or a cosine function is. That's like the main cycle that the function is making, right? So sine, as it traces out the unit circle, is going to make a cycle that looks something like this, and then that will repeat itself over and over again. The fundamental cycle that we're graphing is just that specific cycle, and so that's what I'm trying to replicate here. So my phase shift will tell me that that fundamental cycle is starting at negative pi over 4. So that cycle, instead of starting at 0, like it usually would, is going to start at negative pi over 4. And so I'll draw a little tick mark, and let me do that in white, actually. We have negative pi over 4. Now, that's where the cycle actually starts. But remember, on a sine function, the typical period is 2 pi. And what that's telling me is that the entirety of the fundamental cycle traces out over a length of 2 pi. And so if I want to find out where the fundamental cycle of this graph ends, it's going to be where it starts, which is the phase shift, plus the entire period. Right? On a normal function, it starts at 0, it's plus 2 pi, so the fundamental cycle ends at 2 pi. In our case, we have, so when does the fundamental cycle end? And that's going to be starting at pi over 4 plus pi. And then I can solve this. Well, that's going to be negative pi over 4 plus 4 pi over 4, right? I'm just adjusting pi to be a fraction. and that's going to get us, not negative, sorry, positive 3 pi over 4. So when does the fundamental cycle end? Well, it's at that point 3 pi over 4. And I'm going to, yeah, I wrote that question down because I want to kind of like have that in context. Anyway, I will try and draw this out accurately. And I guess now that I'm, can I? Oh, here we go. Okay, I can make that nicer to look at. All right, so I'll try and space this out, but like we'll have, I don't know, 3 pi over 4. Please forgive if my graph is not super accurate, but now I know that my sine function is both going to begin and end at these points, right? And one other thing, let me just interject with, one thing you want to keep in mind is the difference between sine and cosine functions, and I'll just do a little drawing down here and then move it. The sine function starts at 0 and ends at 0, where the cosine function starts at 1. That's really ugly. Starts at 1 and ends at 1. Let me try and make that a little neater. Okay, that might be as good as we're going to get. But just keep that in mind. So everything I'm doing here can apply equally to a cosine function. We're just going to change the way in which we actually start off our cycle. Anyway, the next thing to keep in mind, right, is that the sine function starts where the period starts, or starts at the phase shift, ends where the period ends. So it starts here, ends here. And then in between that, I'm going to have one peak, one more axis intercept, one valley before returning back to where my period ends. The thing we can notice about that pattern is that every single one of those occurrences happens at exactly 1/4 the way as we travel from the phase shift to the period. And so what I mean by that is all of our points of interest happen at the quarters, right? So if I split this graph sort of into fourths, and let me try and not make this horrible. Okay, I got to pick a color. So I guess my splits are going to be in green. But, oh boy, all right. Bear with me, I'm not the best at using OneNote. Okay, I have a split here. See, why is it doing that? Anyway, let me draw it by hand. I'll make it a dotted line. Oh, that's pretty close. Okay, so we have a split at the green, then a split in the middle, and then this is going to be your 1/2 split, and then we have another split, one more fourth from there. And I know this isn't the most visually appealing image. What I'm trying to convey is I've split this into 4 parts. Oh, can't count today. I split it into 4 parts, and at every single one of those intersection points, I'm getting another critical point of interest. That's what I'm trying to argue here. And so if we think about what our sine function looks like all the way down in blue over here, well, I have a point that starts at 0. I know that. Then at the first fourth, I get a point at 1. At the next fourth, which is the half, I get a point at 0. And at the third fourth, I get a point at -1. And so I can try and draw this. Let me add some axis intercepts. My first point, my fourth, happens at 1. Then I get a point that happens at 0. And then I get a point that happens at -1. And that's perfectly accurate, right? And if I want to actually find out what those are, because it'll be useful to label those axis intercepts, I can just kind of do some math, right? So we already know that my period is pi, right? So the whole period is pi. And if I split pi in the quarters, I'm counting by pi over 4. And so I can count these tick marks well. And let me erase the green really briefly. So get rid of the green, get rid of the green. Okay, because I'm just trying to demonstrate. So I'm going to actually go ahead and label these points. Well, the first one, -pi/4 plus pi/4, that's 0. 0 plus pi/4 is positive pi/4. And then if I have pi/4 plus pi/4, that's 2 pi/4, which simplifies to pi/2. And so that's how I form my tick marks on my graph. That's how I kind of figure out where each point is. Now to finish it off, I can just fill in the graph. And this isn't going to look very pretty. I'm warning you right now. But you want to try and kind of capture what that curve looks like. So, oh, that's horrible. All right, hold on. Let me lock in for a second. It's going to peak, and then it's going to move back down. It's going to intersect. It's going to come down and intersect and come back up like this. All right, that's not horrible. I'm kind of happy with that. But my point still stands. These are our critical values that we found using that like 1/4 method, and I was able to calculate where those points actually lie. So in summary, because I do want to summarize what I did, right? So you can apply this to any trig function. What we did first is we found out our important things, right? We did period, we did phase shift. Those are the big ones. We used phase shift to start our graph. So that's how I know where my graph started, or my fundamental cycle started, because remember, the sine function is going to keep looping forever and ever and ever, so I can keep repeating this yellow graph. Then I took that phase shift, I added the period, and found out where my fundamental cycle ends. And then from that point, I used the 1/4 rule to draw those vertical lines. So I found out where my additional points of interest are going to lie. And maybe I did it a little bit out of order. That might have been a good time for me to calculate, 0, pi over 4, pi over 2, but, that's splitting hairs. And then at that point, I said, okay, well, what am I dealing with? Do I have a sine function? Do I have a cosine function? And based off what we said, okay, do I have a sine? Do I have a cosine? That's how you know, all right, am I starting at 1? Am I starting at 0? And then also keep in mind that, like, if our amplitude was different, if I had an amplitude of 4, well, instead of starting at, say, or instead of my valleys and peaks being at 1 and -1, it's going to be at 4 and -4. And if my baseline was different, then instead of resting at 0, the whole function would be shifted up an amount. All of these specifics are kind of like extra details that come across in other problems, but I really want to make it clear, like, graphing sine functions and cosine functions aren't that bad. Find the phase shift, find the period, kind of set your boundaries of where the fundamental cycle will lie, do the 1/4 rule, and then just fill in the rest of the information. Take it slow, promise you can do it, but that is a worked example on how to graph a sine or a cosine function.